In the circuit shown in figure 2562, the batteries have negligible internal resistance. Find A, the current in each branch of the circuit, B, the potential difference between point A and point B, and C, the power supplied by each battery. Okay, so I assume that this battery here giving the current to the circuit here. So I will have this one here goes up like this, and I will name this as I1. And that current I1 eventually will goes into this resistor, and I will have I1 here because that is in series, right? This battery and this 4 ohm resistor are in series. And the same with this 12 volt battery here. Let's also assume this goes into the circuit here, and let's name this I2. And because this is in series, I will have this one here also I2 because that is in series with this current. And for this 6 ohm resistor, I will have it like this, and I will name this as I3 here. And for the potential difference between the resistor, I will assume that where the current comes from is the positive side, so I will have like this, and where the current goes is the negative side. Okay, so for this one, I also goes like that, so I'll have plus here and minus here. And the same for this one, where the current comes from is the positive side, and where the current goes to is the negative side. Okay, now let's see here, we have a junction at A, so we can have the Kirchhoff junction rule at A. Okay, let's do the junction rule at A. And the junction rule said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And there are two currents that goes into this node here. So we will have I1 is the first one, right? So this I1 is the first one that goes into point A. And then I2 is the second one that goes into point A. So I have I1 plus I2. And the only current that goes out from point A is I3. So we will have this will equal to I3. Good. I think that is the only junction rule that we can do in the circuit. You can also do it in B and you get the same equation here. Good. Now let's do another Kirchhoff rule, but this time is the loop rule. Okay, let's name this loop here as loop 1. Why I do it like this? Because this current looks like this, right? So I just do it clockwise on the loop 1. But for the loop 2, this current goes up, then to the left, then goes down. So I think I will just follow that. So I will go counterclockwise on loop 2. Like this. Okay, now let's do the loop rule at loop 1. Okay, and the loop rule said that the sum of the voltage in a loop will equal to 0. Good. Now, we have to be very careful about the sign here. Let's start from this battery here and the loop entering from the negative terminal. So we'll have minus here. We'll have minus, and the voltage here will be 12. Good. And then let's move on to this resistor here and the current entering from the positive terminal. So we'll have plus sign. And because this is resistance, we need to multiply it by the current to get the voltage. So 4 times I1, right? And then what else? We will have this one here. So here the loop entering from the positive side. So I will have plus. And we will have 6, and the current that passed through this resistor is I3. All of that will equal to 0. Good. Now we will have 4I1, and then plus 6I3. But then I3 is I1 plus I2. Okay, let's give it to him. So I will have I1 plus I2. Let's substitute that. So we will have all of that, let's move this minus 12 to the right hand side. So I have 12 here. And so we will have 4i1 here, 4i1, and then plus 6i1 plus 6i2. And all of that will equal to 12. 4 plus 6 is 10, so I will have 10i1, and then plus 6i2 here, and that will equal to 12. And I think nothing more that can we do from here. Let's do another loop rule, but this time at loop 2. Let's do exactly that. Okay, loop rule at loop 2. Again, the loop rule said that the sum of the voltage in a loop will equal to 0. But I ran out of space. Let's clean this up first. Okay, now let's play the same game, but this time at loop 2. Okay, here the battery here. Let's start from this battery and the loop entering from the negative terminal. So I will have minus sign here, and the voltage is 12. Good. And then we move on to this resistor here, and the loop entering from the positive terminal. So I'll have plus sign, yeah, because it's entering from the positive terminal. And then we will have 3 ohm. And then for getting voltage, we multiply it by I2. So I'll have I2 here. Good. And now here we have this 6 ohm resistor. And again, this loop entering from the positive side. So we'll have plus, and we will have 6, but this time is I3 here. All of that will equal to 0. So we will have 3I2, and then plus, we will have 6I3, but I3 is I1 plus I2. So I'll have I1 plus I2. Okay, and let's move this minus 12 to the right hand side. So I will have 12 here. Good. So now we will have 3I2 plus 6i1, and then plus 6i2. Okay, all of that will equal to 12. And then we will have 6i1, and then plus 9i2. And all of that will equal to 12. Okay. Now we have two equations with two variables, right? So we'll have this one as equation 1 and this one as equation number 2. We should be able to solve them. Okay, let's solve them. Okay, now we need to solve 1 and 2. Okay, how to solve that? I think we need to multiply the equation 1 by 6 here. So we'll have 6 times 1. And then equation 2 by 4. Okay, 4 by... Okay, so we will have this one here. So we'll have 60i1 plus 36i2. And that will equal to 72. And then we will have this one here. We will have 36i1. And then plus 36. Not 36. Oh, 6 times 4 is 24, not 36. Okay, this one will be 24. Have 24. And then we will have 36i2, and that will equal to 48. Okay, let's subtract this. Good. So we will have 60 minus 24. That will be 36, I think. 36i1. And then this will cancel each other. 72 minus 48 is, I think that will be 24. Yeah, 24. So we can get I1 here is 24 divided by 36. 24 divided by 36, or we can have this as 2 over 3, right? So we can divide this by 12. So I have 2 over 3 ampere. Good. So I1 here is 2 over 3 ampere. And I think that is a good value here, because we can also have this into, let's plug this into equation number 1 here. Oh no, I think we can easily plug into equation number 2. Okay, so we will have 6I1. So we'll have 6 multiplied by 2 over 3. And then plus, we will have 6I2. And that will equal to 12. Okay, so we will have this will equal to 2. And so we will have, this one is 4. So we will have it like this. So we'll have 6I2. And that will equal to 8. And therefore, we will have I2 is 8 divided by 6. That will be 4 over 3 ampere. Okay, so we have I1 is 2 over 3 and I2 is 4 over 3. And from here, we can calculate I3, right? Okay, maybe let's clean this up. Okay, now we can plug I1 and I2 to get I3, right? So we will have I1 here is 2 over 3. And then I2 is 4 over 3. And that will equal to I3. Okay, this is fractional addition. So we'll have 6 divided by 3, right? So I'll have I3 is equal to 6 divided by 3. And so we will have I3 is 2 ampere. And that is the answer for question A. So we will have I1 is the current in this branch, I2 is the current in this branch, and I3 is the current in this branch. So we will have I1, I2, and I3 already. Good. And then now let's answer the question B, the potential difference between point A and point B. So we need to find out VAB. And we can just use Ohm's law here. So we'll have I3 multiplied by the resistance. So we'll have 6. And I3 is, what is I3? I3 is 2 ampere. Okay, so I'll have 2 multiplied by 6. And so we will have that equal to 12. And so the VAB here, the potential difference between A and B is equal to 12. And the unit here will be in volt. Good. And this one is here. Okay, and then C, the power supplied by each battery. Okay, we can just use this formula for the power here. So the power by battery 1, okay, maybe let's name this as E1 and let's name this as E2. So the power supplied by the battery E1 here, that will be the voltage. Okay, so we'll have 12 multiplied by the current. The current is I1, so we will have 2 over 3. And so we will have this cancel into 4. So we'll have 8 watt here. And then the power by this battery here, E2, that will equal to, we will have 12 multiplied by 4 over 3. Okay, and this will cancel into 4. So we will have 16 watt. And I think that is the answer for question C. So it is 8 watt and 16 watt. Thank you for watching. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye-bye.